This unit's a continuation from last year. You've seen these figures before. You've done volume and stuff before. We're just doing surface area and volume, nothing special. Ready? Not ready? What's the difference between a prism and a pyramid? What's the difference between a prism and a pyramid? So you probably know what a pyramid looks like because you probably studied Egypt at some point or some ancient civilization. These are all pyramids. Why? What's different from these guys and these guys up here? They come to a point, so I'm just going to highlight the point in red. Kind of, yeah. So a prism, the mathematical definition, it's a 3D shape. What does 3D mean? And what are the 3 dimensions? Close, length, width, height. A 3D shape with 2 equal bases. A 3D shape with 2 equal bases. Grab your coloring instrument, highlighter, marker, whatever. I'm going to color the base on this one. And then it's got the exact same shape on the top. You don't have to draw them, you just have to color. We call this a rectangular-based prism because we're not creative people. And what's the base shape? Rectangular, so it's a rectangular-based prism. This middle one's a little bit funny because it's not standing on end, it's like pushed over, so the bases are actually on the front and the back. Hi. It's the note package from this unit. There should be, if there's extras, they'll be up there. What do you think we call this middle shape? Triangular-based prism. So by base, it doesn't necessarily mean the bottom. Could be pushed over like this one. This one is also a prism, but it's got a special name. Anyone remember from last year? Cylinder. Or we call it circle-based prism, even though they look like ovals when you draw them. So to find the surface area of any of these shapes, we just add up all the sides. To find the volume, it's the area of the base times the height. And I'm going to give you the actual formulas for the cylinder because it's a little bit tricky with the circles. So surface area for a cylinder is 2 pi r squared plus 2 pi r h. What do you think r stands for? So 2 pi r squared is the top and bottom circle. 2 pi r h is the part around the middle. And the volume is 2 pi r squared, pi r squared times h. So area of the circle times the height. You don't need to memorize that. It'll be given to you with any question that you need it. Times h, pi r squared h. Pyramid is also a 3D shape. With one base. That's the difference between a prism and a pyramid. Pyramids have one base, prisms have 2 bases. Here the base is on the bottom. We would call this a triangular-based pyramid because the base is a triangle. Middle one, what would we call it? Could be square, could be rectangular. We don't know for sure. So typically we would say rectangular-based prism.
We said square-based.
If it was marked that it was a square. Third one is an oval, even though in real life it would be a circle. It also has a special name. Cone. Yeah, like an ice cream cone if you tip it over. The surface area formula is exactly the same. It's area of all sides. However, the volume formula is different. What's different? It's 1/3. And again, I'll just give you the formulas for a cone. Surface area is pi r squared plus pi rs. Pi r squared plus pi rs. What the heck is s? You'd think, but that's SA. It's called the slant height. So it's the side. And they call it the slant height because it's slanted. It's not perfectly up and down. So S is just the side of the cone. And the volume would be 1/3 pi r squared h. Pi r squared h. Where would h be on this diagram if slant height is the side? Yep, the dotted line down the middle. So that's the difference between h and s. So we're just going to practice finding surface areas and volumes. Nothing fancy today. First one we're going to do a shape that's made up of blocks. And so we call this an irregular figure because it's not just a regular pyramid or prism. It's got a whole bunch of different shapes to it. How many sides does this irregular figure have? How many sides? So it's got a top, and it's got a bottom. It's got a left and it's got a front and a back. So how many sides does it have? 6. So we're going to draw out all 6 and then just count. So we'll do the top and bottom first, then the front and the back, then the left and the right. And so this is using a different side of your brain than the math side. This is called the spatial relation, which is very much right-sided, and it's looking at how did the sides relate to each other. So you have to kind of pretend for the top that you're looking down on top of this thing. How many rows of blocks would there be if you're looking at the top? How many rows would there be? 2. There'd be 2 rows. How many blocks are in the back row? So I'm going to highlight or color in 3 blocks. How many blocks are in the first row or the front row? And where are they in relation to this 3? Left and in the middle. What about the bottom? It's going to be identical. It's going to have 3 in the back, 2 in front. Or you could flip that and do it opposite and have 2 in the back and then 3 in the front. It's not going to matter for the surface area. Either or. It depends if you're tilting the object towards you or away from you. Okay, what about the front? How many rows are there going to be? So you're going to have 1, 2, 3. Let's go with the top one first. How many blocks in the top row? How many blocks in the middle row? Hi. No. If you're just looking at the front, how many blocks are going to be in the 3? Or in the, I just told you, in the 3rd row. There's 3. What about the back? Same, except it's going to be backwards. Give me a math word, maybe something that we've done in this unit. A reflection. So you're going to have the 2, or the 1, sorry, in the bottom. For the left, you either have to imagine turning this thing or you have to imagine looking at it from this way to get the left-hand side. What are we going to see on the left? An L shape. Okay, how many are on the left-hand side of the L? 3. And then 1. Perfect. And the right-hand side, we have to imagine looking from this way. And what's maybe a math word to describe what's going on here? Reflection. How many squares did we color with the top? How many did we color with the bottom? How many did we color in the front? How many at the back? Left? And the right? How do we figure out the total surface area? Add them up. Offer of 30. And we would call this units squared. Why the little squared? Because it's surface area. And why does surface area have a little squared? Because it's two-dimensional. Two-dimensional. Volume will have units cubed. Questions on irregular objects? Okay, let's go to regular objects. Why did I highlight square-based? I did feel like it, but why did I feel like it? Yes, so if we look at the shaded part, which is telling us the base, we're only really given the height of it here. What do we know about the width? It's going to be the same, so this is also going to be 2. We're going to do the same thing we did in the last question. We're just not going to draw it out this time. We're just going to calculate. So we've got 6 sides. We've got the front and the back, the bottom, and the top, and the left, and the right. We could draw it, but we'll just calculate it. What will the dimensions of the front be? What times what? 8 times 2, 2 times 8, total of 16. Well, what do you know about the back? It's got to be exactly the same because it's a regular base prism, so it's got to be identical. What will the dimensions of the bottom be? 8 times 2. The top? Exactly the same. The left? 2 times 2 for a total of? The right? What do we do with all those 6 sides? Add them all together. Offer of 72. B, imagine we glued a rectangular base prism to the top of the box. And I meant to say pyramid in that. Let's change that. To the top of this box. If its height is 10 centimeters, what is the surface area of the composite figure? What the heck is a composite figure? Combination. Two figures put together is called a composite figure. So what we're going to do is put a pyramid right on top of this, so like the roof of a house. So I'm going to put that dot to be the top of the pyramid. And then I'm just going to join that dot to the top four corners of our box. Use the side of your phone, use the side of your calculator, use the edge of something straight.
My line's not very straight. You gotta make 4 line drops. So did mine.
The issue with composite figures is we're now not going to have all the sides of the two figures together. If we were to glue these together and imagine we were going to paint it, would we have to paint all 6 sides of the bottom?
Yeah. No, you paint 5.
You would paint 5. Which one would we not paint? The top of it. What about our pyramid? Would we paint all the sides of our pyramid? We wouldn't paint the bottom because they're glued together. So we're going to find the total surface area, then we're going to subtract off those sides we wouldn't paint. So the prism we already know from above is 72. Now we have to deal with the pyramid. How do you find surface area of a pyramid?
One third of the base times height.
He sounds so convinced with that, though.
I was not at all.
That 1/3 isn't for surface area, it's for volume. How do we find surface area of a pyramid? Okay, so we got to figure out how many sides does this pyramid have? Well, how many triangles is it going to have front, back, left, right? So it's going to be made of 4 triangles plus the base, which is what shape? Now for this particular pyramid, do we have to worry about the base?
No.
Why not? Because it's going to be glued. So I'm going to just ignore that base and then I don't have to worry about it at the end. Are all 4 triangles going to be the same or are they paired off? So the front and back triangle are going to be the same and the left and right are going to be the same. So front and back triangle, left and right triangle. What's the formula for area of a triangle?
Base times height divided by 2.
Perfect, base times height divided by 2. So if we look at the front of this triangle, what's the base?
8.
It's got to be 8 from the question above, so we're going to have 8 times 10 divided by 2.
40. Wait, is that for the front? Okay.
It's just for the front at this point. We'll do the back in a second. Offer 40 for the front. But then how do we account for the back? We times it by 2. Squished in there, 80. The one that's on the left and right, what's the base? 2 centimeters from above times the height divided by 2. Times by 2 for the left and the right. Questions so far? Going back to the prism, we got to account for the fact we're not going to have the top of it, so we've got to minus off the top. How do we find the surface area of the top? Look at the diagram above. It was 16. Is that confirmed?
No, 56.
Is that confirmed? So we got our 56, we've got our 80, ooh, off the page, we've got our 20, offer of 156 centimeters squared. I kind of talked about C already in B. Imagine we wanted to paint. What sides would we not have to paint? Top of the prism, bottom of the pyramid. We call these overlapping sides. And I realized we kind of did it above in B. Find the surface area of the cylinder. Straight up question for this one, and then we'll do a composite where we stack it on top of something. Well, we kind of did it above, because I already subtracted them off. Okay, I gave it to you already. What's surface area of a cylinder? Something with a bunch of pies, yeah.
Oh, it's 1 times pi.
How about we look back and not guess?
No, it's radius times pi. Yes, it's 1 times pi. Pi r squared. Wait, no, it's 1 times pi. I don't know. Something to the power of.
It's kind of painful.
No, pi r times 2 pi r squared. Wait, what are we talking about? Surface area. It's looking at the flash of the light in my eye. That's why.
Kind of painful. 2 and pi are numbers, so we just leave them in the formula. Do we have a value for r?
Yes. 1.
Do we have a value for h? 3. Do the ones really matter in this calculation? No, so you can actually ignore them when you type it into your calculator. Hang on, grab a calculator.
It says pi.
Yeah, we're past punching in a value for pi. That's grade 8. Now you have a scientific calculator that should have a pi button on it. So if you're using your phone, you might have to tilt it sideways. And it depends on your phone where the pi button is. 2 times pi. And then plus 2 times pi times 3, and then enter. So 2 times pi
25.1.
plus 2 times pi times 3 equals.
25.1.
If we go to 1 decimal place, 23.1, you said 25 before. 25.1, looking for confirmation. Okay, if you didn't get that, clear it out and I'll repeat it again. 2 times pi, 2 times pi, plus 2 times pi times 3 equals.
I did the whole equation together.
That's fine. Times 3 equals. Equals. Everybody else get that as well? Units. Okay, David, clear it out and punch it with me now. 2 times pi plus 2 times pi times 3. Got it? Got it? Okay, all we're going to do now is stack our cylinder on top of this box. What we need to figure out is what are the overlapping sides. So what would we not have to paint if we were going to paint this?
The bottom of the cylinder and where it goes on the thing.
Perfect. So bottom of the cylinder and then where it goes on top of the box. Well, what's the shape going to be where it sits on the box?
Where the area of the bottom of the thing would be.
Right, so we're going to have to subtract off 2 circles.
The R is right.
R is right here.
I mean, in the center.
I don't know what you're talking about. Try again. Like the radius, is that what you're asking? So that's R there?
O is half.
Yeah, it's half diameter, goes the whole way across. Did that answer your question? Okay, so just keep in mind we're going to have to subtract off 2 circles. How do we find the total surface area of this figure?
You gotta add all the things together.
Okay, so we've already done the cylinder. Now we have to do the prism. We already did a prism a few examples ago. Okay, that would be volume again.
It's length times width times.
Volume.
Length times width.
Area of all sides.
Area of all sides. Let's go to our front and back. There's going to be 2 of them. Give me 2 possible dimensions. We don't care as long as we use all the combinations. 6 times 3 would be a good one to start. And then we're going to also have 2 times 2 times 6. And then we're going to have 2 times, what's the only combination we haven't used? 3 times 2. Okay, 6 times 3 times 2. Offer of 36.
16 plus 6 is 32.
So do we have confirmation on that? 30. 2
36.
times 6 times 2. 3 times 2 times 2. Add them up.
72.
A really fast 72.
42.
So the surface area right now will be the total of these together. Ooh, plus. Offer of 97.1. Looking for confirmation. But what have we not subtracted yet? The 2 circles. What is area of a circle? So 2 of them would be? 2 of them would be?
2 radius.
2
2 R.
pi r squared. That was painful.
So 1 comes in.
What's the radius of the circle?
1.
So do we really care about the 1 squared?
No.
So on your calculator, you get 2 times pi.
6.28818532717586.
Keep going, keep going.
I don't have 6.3 minus 6.3.
Can I go 90.8 to 1 decimal place? Looking for confirmation. Some units?
Meters squared.
Last one.
Yay! One more.
Read to read. I like cake too. pretty small wedding cake. I don't know. Wouldn't feed many people.
Wait, so the D, like, is equal, like, the straight line?
Carter, what did you do to me?
Someone must have rigged it.
Not the Mexican.
Brandon, can I have your focus, please? David, no touchy. No touchy. The bottom. But then if you were to take the cylinder off, you'd have an open circle on the square.
Used to coach soccer the Olympics.
Just waiting till you're more focused.
Wedding cake. What? Two-tier. Does the two-tier mean anything?
What do you want to highlight? What's important?
Two-tier. Is that like layers?
Hmm?
Calculate the surface area.
What will not need to be iced?
The bottom of the top tier. What if it's like icing in between? Yeah.
Typically, we don't to save money.
But like, what if
How
the
does it
rim?
stick together then?
Like this
Don't you just ice like the top of one and then not ice the bottom?
Yeah, I don't put icing in the middle. I think I would put jam or something in the middle. Something yummy. Fudge. Ooh. Ooh. I don't really bake. I'm not a baker. What about the very bottom? Do we ice the bottom?
No.
Then it will slide right off. So one circle. I'm going to put small and big.
We should make a cake this class now. Just like
Where we actually ice.
Okay, so let's do tier number 1 first. What's the shape?
sphere.
We did not do a sphere at all. There was no sphere anywhere so far. You have a cone, you have a cylinder. That's it.
Sphere would be a cool cake.
Give me the formula for surface area of a cylinder.
230 times volume again. R squared plus 2 pi r squared.
No squared on it. Let's talk about what this part of the formula represents.
Area of the 2 circles.
So if we need to subtract off 2 circles, then just don't even do that piece. It's going to make your calculation easier,
And then you gotta take 1 off the other one too, though.
which we'll get in a second.
We just do 1 pi times RH. $30 and 4. Oh no. Well, one of them is 4. Isn't it 20 and 4?
10 and 4.
Ooh, just high five to you. Where did the 10 come from?
Because diameter is the full and radius is the half.
Oh, I guess we gotta do this on our calculators. Times pi. This is other flip. Times 10 times 4 equals 251.3.
Confirmation.
What? What do you get? 251.3. Okay. Centimeters. I got that one too.
Okay, what about tier number 2? But just be careful how many circles are we subtracting off this one. So how are we going to change this formula? Again, you can do it the long way and subtract them after. This is just making the work a little bit less. Ooh, where did 15 come from? Mm-hmm.
Is it supposed to be 251.2 instead of 3?
Just we want confirmation on this 3. Eric thinks it might be a 2.
No, it's 3, 2, 7, 4. Because it goes 51.32.
So there's a 2 after the 3, so let me leave it as 2. There's 3. Remember we talked in the exponent unit how to get an exponent of 2? Well, that would be the grade 8 way to do it. Remember there's a special button.
Oh, yeah, it's a square button.
So it could be y to the x, could be x to the y. You might have a squared button. You might have a hat. Totally depends on your calculator.
I got an X and a Y. It's 225. Yeah, it's 220.
1,413.
Oh, with all pi and everything? I should have pi. What the heck did I do? 15.
What button is it for me again?
What'd you get? I got 895.
Somehow I
That's
ended up
726.
Nick, what? I ended up 1.37568.
Now we've had 5 different answers.
I have 1,083 points.
I got 706.
But
I got 895.
Two people got the same.
I got 1.3756842.
Yeah, that's definitely wrong.
What'd you get? 235? I got 235.
I got 7 points.
I effed up bad. Mine's like 1 point, like a lot of numbers.
I got
8 plus 8.
716.
I have.
No, on the top. Pick
Which
one.
one is it?
I got 7.
No, on the top.
You should do it. Do it.
I'm waiting for you guys to confirm.
1,083.
I think it's just us that got that. Oh, no, 3 people got
4 people.
1,083.84.
I got.
Sorry, Jess, what point? Jess, point.
What the heck am I doing?
Centimeters.
Just looking for confirmation on this.
Yeah.
Yeah. Centimeters.
That is nowhere close to what I got. I got like 18 decimal points.
And we add the first 2 together, right? Plus 2 and plus 4. 1,335.1.
Sorry? Yes.
So 1,335.1 centimeters squared.
Looking for confirmation on the final. Make sure you write down the questions for homework because they're not on the calendar. Start with the scariest one now, get it out of the way.